Robinson for Tech Talk Tuesday. Today we will be, Kenny will be explaining his Raspberry Pi traffic light project. But before Kenny gets started, I wanted to take a moment to introduce him, to give you guys an overview of who Kenny is and what he does. Kenny is a programmer analysis associate that has worked with IT information technology for over 10 years. In his current role, he builds and maintains web-based applications that are used for various purposes, and those are apps.
Yes.
Kenny is a native of Birmingham, Alabama. He earned his Bachelor of Science degree in Business with a specialization in Business Information Technology from the University of Alabama. As an active lifetime member of NASB, which is the National Society of Black Engineers, they have a page. You guys can join and follow them. It's a great organization. He inspires the future generations of STEM professionals through his community outreach programs. When Kenny is not on the computer, when he's taking a break from the computer, he enjoys sharing his DIY projects and gardening successes on his YouTube channel and blog, thealmostengineer.com. So you guys follow him. Thank you, Kenny, for joining me today. I appreciate having you here.
Thanks for having me.
I'll let you take it away.
All right. So what I have is basically a pet project of mine. It is a traffic light. This actually is a real like used to be in service traffic light. I bought it probably about 2-3 years ago, and so it has it did not come with a traffic light controller. And so what I did is I built one using a Raspberry Pi, and to do that required me to learn Python. I was in school at a time where using Python or learning Python was not a thing. So basically I had to learn it from scratch. So I did do that. I also have a background in electrical engineering because that's what I initially started with in school. And so that's how I'm able to know how to wire this up, correctly without blowing anything up. And so from that, I built out all the code and have taken it to like various, like demonstrations to like schools and community events and basically teach students STEM, so this in particular is the electrical engineering and computer science aspects of STEM, because in here you have to know how to understand the 2 different voltages that run this. So like the actual light itself runs off of the same as like a standard household, which is 120 volts.
Okay.
But the Raspberry Pi uses 5 volts, which is way less. Usually like your phone or something like that nature runs off of 5 volts. So being able to know how to use those 2 without crossing them is essential. And then of course the computer science aspect of it is actually programming what the Raspberry Pi does and so forth. Okay. Any questions? Okay, so I have this code that's running this is available on GitHub. If you go to my website, thealmostengineer.com/GitHub, it will redirect you to another page, and on that you'll look for a repository named Traffic Pi, and in that repository it will have the code, the setup, how you can basically build this yourself. All the pin diagrams, everything. Because the concept behind it is that, I built it, but I want others to be able to experience it, be able to understand the details behind it, and so forth. And so, all of these components, the traffic light as well, you can buy online.
Yes.
And so, in total, this is probably maybe $200 to $250 worth of parts and components put together. And then you can copy the code as is, and it'll run right out of the box if you wire things correctly.
And I want to just say that I looked at some different projects, and you guys don't have to have an actual traffic light. There are some LED lights that can be connected as well for a more affordable option. Now, you will have to have the Raspberry Pi.
You'll still need the Pi, and you still need the, if you just do the LED option, you just need the Pi.
Okay.
because it'll run without the LCD. You have to change I think it's like a value in there, but it'll run without that.
And how much with the Raspberry?
So the Pi is $35. This one is a Raspberry Pi 3. There's actually a Raspberry Pi 4 out now. But it's essentially the same concept. I think that one has more memory and a faster processor. That's the only difference. But everything else is pretty much the same on it. Let's see what else. So going back to the electrical engineering point, each of the wires represents that. To most people, it's just like it's a bunch of colors, but each wire actually has a unique purpose in it. And so, in saying that, this is how a little bit more of that electrical engineering aspect of things, because of the fact, like the red represents red, yellow represents yellow. But in the electrical engineering world, when you use green, it represents brown. So they don't actually have a green wire in here. Instead, this wire actually that comes out of here is brown, not green. And so, but I have it as black because brown wire is pretty hard to find. Okay. But yeah, and so same thing. So I tried to match so this wires here are for the actual lights, but then the relay has its own set of wires that go to the Raspberry Pi and the corresponding wire colors, so that you know which is controlling which, so forth, for consensus purposes. Let's see what else. And then the LCD. So actually, the LCD I did not write the code for. There's a guy on GitHub who goes by the name of the Raspberry Pi guy. And so what he did is he created a Python library that actually can do all of that. And basically, you just call a couple of functions in your code, and it will go get that code and display out. So part of that is reusing components for various purposes. No questions? Okay. So if you all have any questions, feel free to ask in the chat box there. All right. So if you go to the GitHub page that I mentioned, I explained kind of how I use this to teach like software a little bit. So I wrote into the code and the ability to write pseudocode. So it's not actual code. It's basically supposed to be like plain English that's described in code. So a non-coder could do this. Yes. And so in the teaching setting, what I do is so I get the students to actually say, all right, how is this supposed to work? And so most people like green, yellow, red. All right, cool. So what happens is when you put green, yellow, red in there, and if you look at the image on the README page for this, what happens is all three lights will turn on. And it's like, well, that's not what I wanted to do. It's like, but that's what you told it. And so after that, we go through a discussion of, wait, so I have to tell it to turn on too? Yes. Yes. You coded it.
Each and every step that you want to take,
right.
You have to have that code.
Right. And so from that, it's like, all right, so we know you messed up version 1. Now you got to do version 2. And then what they learned is that because they know how it's supposed to work, and because what they're trying to code is not working, they understand that, okay, if I code this wrong, and this would actually be put out into the real world, people would get hurt,
yes.
Cause property damage, those type of things. And so they work through several cycles to get it right. And in the image that's on the GitHub page, there's actually 4 cycles. But when you get like massive classrooms, they'll get it in like 2 to 3 cycles. Okay. So
they have to work together.
Yeah, well, they don't have to, but we try to get them to work together. And a lot of it, you find some funny aspects of it where they're like, it's red, yellow, green. It's like, no, it goes the other way around. And it's like, wait, what? And it's like, we're talking about the order. And so that, and then also the concepts of how it's supposed to work. Some people know a little bit better than others, because of age differences. Okay.
Adrian said, did you do this using a code?
Yes, so it's written in Python. The whole thing is written in Python. This does have a web interface, so I'm able to change the program of it using my phone. So that part of it is written in PHP. It's just a single web page with a form on it and a selection list of all the programs that it knows about. And so all I gotta do is go to the web page, change it, save it, and then that, as it goes through another cycle, every time it starts a new cycle, it checks to see if that has changed, and if that's changed, it changes the program. So yes, everything is in Python except that one web page. Any more questions? Okay. All right. So that covers how I use it to teach it to students. Let's see. So if you want to build one of these yourself, again, you just get the parts. This traffic light was I bought it from eBay, in case anybody's wondering. Usually like, did you climb a pole? No, I did not climb a pole and take a
He did not steal the traffic light, y'all.
Right.
Everybody's safe.
There was a guy on eBay. He actually runs a salvage yard, and so he could, and I guess as they take him out of service, he goes and buys it.
Yeah.
And so when I bought this one, he had probably like 5 other ones, and I think he even had some crosswalk signals. So basically, I bought this. It was about $100. And so the various components in here, you can put them together. Again, you don't have to have a traffic light. LEDs will do the same thing. But if you do use a traffic light, you have to be actually mindful of the electrical part. And so, because I believe on one of the posts, somebody asked a question like, is this designed for kids? If you use it for kids, you can use the LED option. But if you want to do the actual full-blown version, I would recommend having no supervision because of the fact of you're using the same amount of voltage that's coming out of the wall, which will potentially damage or death. But just the 5 volts that come out of the Raspberry Pi, you can touch it and it won't bother you. You might get a little zap, but most of the time you'll be fine.
Something kids like that.
Yeah. And so, but it's fairly easy to build. Like I say, the connections, wiring, everything is all on the GitHub page. And I did do a coding session earlier this month, and I actually went through the code that this is built out on. And so I didn't get through the entire code because it's several hundred lines of code. Yeah, but that session, you can check it out. I have a YouTube page, thealmostengineer.com/YouTube. And on there, if you search for coding session in Python, it'll come up. You'll see a traffic light on there or something like that nature. And you can watch that, and it has where I describe the various functions, basically how to code in Python and how I built this out in Python. The actual wiring and so forth, I'll probably do another video in the future that actually discusses that a little bit more. That's more of the electrical side of things and not so much the coding side.
Okay.
All right. More questions?
I just added more things.
Okay. All right. And so, again, if you have any questions, feel free to ask. Now's the time. If not, you can reach out to me later and I can answer those in as well. I'm trying to think what else is on here.
And if you guys are just wanting to jump into computer coding and learning Python, this would be a great.
This would
be a good.
This would be a little bit challenging, I would say, but it is you can do it. So let's say maybe you don't have a use case for building a traffic light. Maybe you want to build something a little bit more simpler. You can do that because Raspberry Pis are also used in like robotics or like automation systems. I think we talked about it where somebody used one to build like an automated garden. And
yes.
So you'll need like a couple more sensors, but essentially you can build that out in a Python script. Home automation, that's another big one that is used for. And
right.
So
turning lights.
turning lights on, you can actually, but the same way that this is wired up, you can kind of do that, but instead of wiring to like this, you can actually have it wired to like a ceiling fan or something like that. That's a little bit more extensive, but the concept is still the same regardless. And then there are other applications. So I've seen where guys, he built a garden and it was fully automated. So it could water, it could monitor temperature, it could turn on fans, it could open like it had what do you call it, like louvers or windows type deal. And so once the temperature at a certain point, the fans will come on and the louvers will open to allow air to blow through. And The only time he really had to go in there and actually had to do something is either when there was not enough water in the reservoir or when it said something was like really off.
Okay.
And so,
And he would have to add sensors.
yeah, so you need sensors. So you can buy sensors. Again, you can go online and search for a temperature sensor. If you're not a fan of doing like the individual wiring, they do make the sensors with the USB plug-in. So all you gotta do is plug it into the USB. Yeah.
Easier way out.
And so, but those cost a little bit more. But you know, if you want to do it, it's the way to do it. So many of use cases.
Personal products.
Yes. Even I know some people have like Roku or Fire Stick or something like that nature. So what they've actually come out with is they've developed a operating system that only runs Kodi, and you install it on the micro SD card, put it in a Raspberry Pi, plug this to your TV, and you have Kodi on your TV.
And that means y'all know Fire Stick is necessary.
Yeah, so no Fire Stick. You don't have to hack your Fire Stick to get Kodi to work.
Because that takes forever.
Yeah.
Y'all try to hack your Fire Stick, and I don't know.
Yeah. So it has many of uses. Depending on which kind of circle you revolve in, determines on what you do and do not know about it coming out. But the concept of this was to actually teach kids STEM things, and so that's why like every time they come out with a new version, it's always $35
because they want to
make it accessible. Yeah. And so and then they have other versions. They have a Pi Zero, which is not even that size. It's actually half of that size. That's like $10. And so, but it doesn't have all the pins or anything on it. You have to put everything on it. So very affordable, great teaching tool, you know, for kids in the classroom and stuff like that nature.
Homework.
Yes.
If you guys are looking for something for your children to do while they're at home and you want them to have this new skill, invest in a Raspberry Pi, $35.
Yep. And so if you do choose to pick out the download the code for this, there's actually a red light, green light game in there. So you know, not too many kids know how to play red light, green light with an actual traffic light. So that's another thing for the kids if they want to, if parents or teachers, if you all want to build this and then have it in your classroom or in the backyard for them to play, you can do that.
We don't have any questions.
No more questions? Okay.
No questions.
Do you have anything?
No, I think you're doing a great job.
Thank you. So I'll be doing some more. I have planned out like pretty much a walkthrough of this. So I'm gonna do a video for how to wire it up and why it's wired the way it's wired and explaining colors. As I mentioned, I already have the one with the Python code and this base here, how you build the base for it. It's fairly simple.
Y'all
So
it's huge. When he brought this in my house, I was like, Key, come look at the traffic. Like, it's huge, y'all. I'm gonna post a picture of him standing next to it when this is over, so y'all can just see how
big it is.
the scale. Yeah.
So each of these are 12 inches. So that means each of these actual doors here are probably like 13 or something like that. So for those of you that can't see the whole thing right now, this actual thing is just over like 3 feet. And this is real scale. They do have so it's 12 and 8-inch size. So the 12 is the more common size now, which is what this is. But the 8-inch size, of course, is a little bit smaller. But yes, they're that big. This one is 25 to 30 pounds. I actually had to weigh it because I didn't realize how heavy it was.
Yeah.
But the metal ones are like 50 to 75. Yeah. And so just picture every time you're driving down the road, there's probably 50 to 100 pounds hanging over your head. You know, kind of a creepy thought when you really think about it.
But
that's it.
Okay, that's it, y'all. Did you guys enjoy? I hope you did. Thank you all for tuning in. Do you want to tell them how to follow you on? Yeah, so if you go to my website, thealmostengineer.com, I have links on there to my Instagram and Twitter, so you can follow me
from there. And you can check out some blog posts. Also, the link to the YouTube channel will be there as well.
Yeah, and Kenny offers lots of live classes on his YouTube channel. I follow him. I watch along. He's great about answering questions, explaining things. So if you, the adult, or your children want to get into computer programming, follow Kenny. He's very much a resource to have. Thank you guys for sharing your time with us. Thank you guys for tuning in. Thank you for sharing the live. For those of you who did, and that's it. See you next Tuesday. I have a 3D printer, and I think I'm going to be doing setting up my 3D printer. But look forward to that, and I have a couple more things planned for you guys. So like, follow, share, all that good stuff, and y'all have a happy Tuesday.